All right, so on the first review here, the first section, the first 10 problems were all multiple choice. You're going to have a similar type of thing on your test as well. So you'll have a group of matching, kind of like how you had on your quiz. Again, some of them might be words from here, some of them might be from the quiz. They might be other words as well. But again, you have that list of 54 words I've posted on Edsby that you can look over in order to see, those are all the vocab words we've done up to this point. I do recommend flashcards if you aren't familiar with them, because again, we're just going to keep building on all those words. So now, on here, a segment whose endpoints consist of a point on the circle and the center of the circle. So that's referring to a radius. A radius, so that would be A, and it's a radius. Again, a radius has an endpoint on the circle and then one on the center. Two angles whose sum is 180 degrees. So when we add two angles and it equals 180, that's supplementary. So that's going to be E. Whichever one you want. I'm going to use this as my key that I'm going to post tonight as well. So it doesn't have to be, it could just be the word. That's fine. On the tests, I'm going to have it as a Scantron for that part of it. So then you can just fill in the bubble. Number 3. An angle whose measure is exactly 90 degrees. So exactly 90 is a right angle. So H. I don't want to put right up there, but it is a right angle. On 4, a segment whose endpoints are two distinct points on a single circle. So that's one way you could define a chord. Because for a chord, both endpoints are on the circle. For number 5, two angles opposite of each other built from two intersecting lines. So if you had two lines intersecting, just two, and they were the opposite angles, so if I drew a picture for that one, it said these two angles here, that would be an example of vertical angles. So that's I, vertical angles. On number 6, two angles which share exactly one of two rays that define them with no interior points in common. That's another way of saying that they don't overlap, right? So this would be adjacent. So J, thank you. Okay, adjacent. Then for number 7, two angles whose sum is 90. So again, 180 was supplementary, 90 is complementary. So that's D. For number 8, a chord which passes through the center of the circle. Well, the only other word up there that is a type of chord is a diameter, which is C. So diameter is a type of chord. And you can say a couple different things about a diameter. You can define it as a chord that passes through the center of the circle, like it does here. You could also say that a diameter is the longest chord in a circle. Number 9, an angle whose measure is between 0 and 90 degrees. So that's an acute angle, which is G. Acute angle. And then finally, an angle whose measure is between 90 and 180, that would be obtuse, which was F. So that's all the vocab in that section. Now, 11 through 15 is naming them based off the figure. So there's a lot of different things you could have named here, and you want to make sure that you name it properly. So this type of section on the test tomorrow will be a fill-in-the-blank, free response type thing, and I'm looking for you to name it correctly and use the correct notation, the correct symbols along with them. Now, if you are just naming points, you just write the points. There's no real symbol that you have to put with it. So on number 11, it says name a line that is coplanar to plane S. Again, coplanar means it's on the same plane. So looking at the figure, here's our plane. This is plane S. We want a line that is on that plane. Well, two lines are on that plane. This other one is passing through the plane. So this one's non-coplanar. We want one of these two that's coplanar. So let's say I did this one. Well, there's several ways you can name that. You could call it line T, using the italicized letter over there. So line T. Or you could name it using the 2 points that are on that line. So you could call it either line ZY or YZ. Either way works. So YZ or ZY, either one works. You didn't need to put all these. I only asked for one. And then also, XW would have also worked. Now, there's 3 points on XW, so you could have done this a couple different ways. XW, WX. You could have done YX. You could have done XY. You could have done YW or WY as well. Oops, YW. So, any one of those is correct for that. All right. Now, I'm not going to give you as many possible options for the test, so you'll be more limited when you come to your answer. I'm not going to have like 10 different things that you can respond with, but there will be a couple different ones. So, with a lowercase cursive or italicized letter, you can name a line. With an uppercase cursive or italicized letter, you can name a plane. So now, on number 12, it says name a ray that is on line T. Well, we have 2 points that are on line T. A ray starts from one endpoint and goes through the other. So we could name either ray YZ or ray ZY. Those are 2 different rays, though. So we have ray ZY or ray YZ. Again, normally you write it in order, starting with the end point and then going through the other point. I showed on the quiz. You could do it backwards, and it is acceptable. I also posted, in case you missed the quiz answers, I posted those on EDSB as well, so you can check your quizzes on there if you didn't get to in class. Number 13. Name 2 points that are collinear with point X. So here's point X way over here. It's on this line. Now, any one other point could be collinear with X. But if I'm saying name 2 points that are collinear with it, they have to all be on the same line. So looking at the line that X is being shown on, here, Y and W are both on the same line as X. So we can list them out as points, and you just have to write them as the uppercase letter. You don't have to put any other symbol with it. So W, and then just comma, Y. Or you could have done Y, comma, W. What is another name for angle? Oh, let me go back to that for a second. If you put a dot in front of it, I'm okay. I'd accept that as well. But you do not need a dot in front of it. All right. So, on 14, name another name for angle 1. Here's 1 right here. It's in this angle. Now, since that angle is sharing a vertex with more than one angle, we can't use just the vertex. We have to use 3 letters.
I have to sign out. Where is it sign out?
Right there in the back.
Oh, okay.
Yeah. So we have angle ZYW or angle WYZ. But again, the vertex has to be the one in the middle. So you have to make sure you use the vertex in the middle and then a point from each ray as one of the other 2 values. The angle sign has to be in front, yes. What point is non-coplanar to plane S? So, all these points are on the plane. The only point that's not on the plane is D, way up at the top.
So if it's asking what's non-coplanar, it means it's not in the plane?
Correct. Yep. Again, now a plane really does extend infinitely in all directions. This, though, since it's showing that this is going through, we know it's not on the plane. That line is definitely not on it. Yes. That says U. So that's line U. I didn't actually use it for anything on here. I just gave it as another option. But yeah. I'm pretty sure that was a U. Yeah, because I did T. Usually I name them. Yeah. All right. Anyway, on 16 through 18, answer the following questions based on the figure below. So on this figure, name a diameter. So diameter has to go through the center of the circle. So going from N all the way through to T, that is the diameter. Now, you only need the two endpoints. Right? So again, a diameter is a type of segment. So you name it using the endpoints. So NT with a line segment over top, or TN. It's only two ways to name that diameter. Name two radii. So how many radii are actually here? We actually have three. Yeah. So now you could name each one of those two different ways, because this could be NK or KN. All right. So we could say, oops, I didn't mean to do lowercase, NK or KN. Then you'd also have KT or TK. Oh, yep. And the last one, you could also do KB or BK. Again, it only asks you to name two. You didn't have to do all three. But those are all three possibilities, and written each of the 6 possible ways. So, yeah. Go for it. That'd be two of the same. So that's a good question. So if it said name two radii, you couldn't just do these two, and that's why I put the or between it, right? Because you can name it this way or that way, but it's still the same segment. So same thing with these. These two are the same segment. So that's not naming two different radii. And then same thing with the last one. So again, you want to name two different radii, not name it two different ways. All right. Good question. All right. On 18, name a chord that is not a diameter. So there's only one chord in here that's not a diameter. Remember, a chord has to have both endpoints on a circle. So that's not a chord, it's a radius. This one going through here, again, that's a chord, but that's the diameter. So the only one that's not the diameter and is a chord is OT. Now again, you can name OT either OT or TO. Either one works. On the other column there, 19 to 20, true or false. So on here I'm asking you to write whether it's true or false, and if it's false, you should be able to give a counter example. So vertical angles are always complementary. False. Give me a counter example. All right, so you could have two vertical angles that are supplementary. All right, now I would accept. You could write it in words, or you could show it to me in a diagram. So let's say we did that supplementary one, because I need to see that it's vertical first. So let's say we did 90 and 90, and I didn't make those perfect 90s, but those two, right? If they were both 90, they'd be supplementary and not complementary. Really, if you had any angles that were obtuse, because that's what you guys told me earlier, obtuse would be another thing that would work. If you had two vertical angles that were obtuse, that would be another thing. So, again, you can either show me a picture or write on words, two obtuse vertical angles. So again, whether it's a picture or in words, both things would work. On number 20, adjacent angles are angles that share a vertex and one side.
True. Oh, it doesn't overlap.
Again, this one is also actually false because it doesn't mention the part about overlapping. Remember, in order for it to be a good definition for adjacent, it has to mention that they can't overlap or can't share the same space. If you look back at our definition that we had over here, right, it says adjacent angles, two angles which share exactly one of two rays that define them with no interior points in common, meaning it does not overlap. So this is the part that's missing on this statement. So we could have two angles that share a ray and overlap. Again, you could write it in words, or if you wanted to give me a picture diagram, that would be fine too, and label which two angles you're talking about. And that'd be similar to one of the ones on last night's homework. So again, in order for a statement to be true, it always has to be true. If there's one counterexample that could prove it wrong, then it's false. On 21, complete this two-column proof by providing the missing reasons and statements for each line. So the very first statement should always be the given. Yeah, this part up top. So we have 3, parenthesis, x plus 4 equals negative 2x minus 8. The bottom part should be our proof statement. So x equals negative 4. Over here off to this side, we need reasons. Well, the first reason should always be given, because we start with a given statement. You have to be given something to start with in order to write out your proof. Now, the next reason has to be what happened from step 1 to step 2. So from here to there, what happened? Distributive. So distributive property. Now, from here to here, it was addition. And then from here to here, what actually happened? Subtraction, yeah. So, subtraction, property of equality. And then finally, the last one they already had written in is our division. Now again, for purposes of this, there are some that are interchangeable. Subtraction and addition could be interchangeable because if you subtract a number, you could say that you're adding a negative number. If you're dividing by a number, you could say you're multiplying by its reciprocal. Alright, so with simplifying, alright, I'm not putting that one on the test, but with simplifying, you could always call that one substitution property as well. But if you were required to do a step where it actually all it did was simplify, that's substitution property because you're replacing a value with an equal value. Yeah. Most of the ones that we go through at this point won't show simplifying because you don't have to. Like the one that we did in last night's homework, it got rid of the fraction by multiplying, and it did multiplying and simplifying in one step. So all you have to list is the multiplication property.
What do you multiply it by? The bottom numbers of the division?
Yeah, so if you have a number on the bottom and it's the same on both, you just multiply that by that number. If you have a number that is, say you have two separate fractions, and the bigger one also would have a factor of the smaller one, then you could just multiply by the bigger one. Or if there's nothing in common, what would those two numbers be when multiplied together? And you could multiply by that number. So again, it's like finding a common denominator in that case. All right. So whatever your common denominator would be, that's what you can multiply by. All right, on the next set. Converse, inverse, and contrapositive. So, 24. They want the converse of the statement. If you are a Leonard student, then you do your math homework. All right? Again, it's not necessarily a true statement. But again, the truth value doesn't matter for rewriting the statements. So, for the converse, we are switching these two around. So, if you do your math homework, then you are a Leonard student. If you do your math homework, then you are a Leonard student.
So, converse, you just switch them?
Switch them. Again. Converse is switch. Inverse is
You add knots.
add the knots, so you're
And then-
negating them.
And then contrapositive, you add knots and you switch them.
That's where you do both, exactly. So now on this one, we're going to go back to the original statement here and add in the word not. So if you are not a Leonard student, or if you want to put aren't, that's fine too. If you are not a Leonard student, then you do not, do not, or don't, I'm just going to put don't, do your math homework. Yeah, HW. Nice try to squeeze in. All right, contrapositive, again, that's where you're doing both. So it should be in the order of the first one, but have the knots in there. So if you don't do your math homework,
Then you aren't a Leonard student. Right?
then you aren't a Leonard student. Now, on 27. Yeah.
So on the certain like put them out of order, like you're not gonna do converse, inverse, and contrapositive.
What do you think? You think I'm going to leave them in order for the test? Now, again, if this is a multiple choice question, which it could be, if it's multiple choice, I probably wouldn't put them in order. If I said to just write them out, then I might put them in order, I might not put them in order. So again, it depends on how I ask it. But there is definitely a question where I switch them around. Yeah. On 27, if the converse is true and the contrapositive is also true, what else should we know? All right, so we should know it's a biconditional statement. What else? Because if it's biconditional, that means that we knew other stuff too, right?
Oh, the other ones are they're logically equal.
They're logically equivalent. What other ones?
The conditional one and the inverse.
All right, so the inverse would also be true, and the conditional would also be true because inverse is logically equivalent to converse, conditional is logically equivalent to contrapositive. So it's biconditional. We would say conditional is true and inverse is true. So again, if they're all true,
Wait, well, I didn't hear past biconditional, but I asked her a question.
okay. So biconditional, we could say it's biconditional because since we know the converse is true and the contrapositive is true, that's enough information to say that they all must be true, right? So the conditional must also be true because of the contrapositive being true. The inverse must be true because of the converse being true. And since all four are true, it's a biconditional statement. Again, you got to remember which ones link together with their truth values, which ones are logically equivalent. Conditional and contrapositive are logically equivalent. Converse and inverse are logically equivalent. Yeah, that's fine. Number 28. Write the following statement as a biconditional if possible. Parallel lines are in the same plane and never intersect. Now, why did it say if possible?
Because it might not be possible.
Sometimes it's not.
All right, so if there was a chance that this is incorrect, or if it was false, then you couldn't do a biconditional. Now, if you are doing a definition, and if it's an accurate definition, you should always be able to write it as a biconditional statement. So here, this is actually defining parallel lines. Parallel lines are in the same plane and never intersect. The first part, we're talking about parallel lines. That's one statement. And then, meaning in the same plane and never intersecting, that's the actual definition. So we should be able to write this as a biconditional statement, because a definition should always be true no matter how you rearrange it. So we could say two lines are parallel if and only if so again, that is the key words that we need when we do it biconditional. So two lines are parallel if and only if they are in the same plane and never intersect. All right. And finally, the last one. The following statement is the contrapositive of a conditional statement. Write the original conditional statement. So again, if they ever tell you to write the original conditional statement, whatever statement they told you they gave you, do that to it, and it'll give you back the original. So if they give you the contrapositive, write the contrapositive of the statement that they're giving you, and it'll be the original statement. If they gave you the converse, and you do the converse of that statement, it's back to the original. If you have the inverse, and you do the inverse of that statement, you're back to the original. So if you just do what it says it was, it'll get you back to the original. So on here, if two angles are complementary, then their sum is not 180 degrees. So we want to switch and negate this to get it back to the original. So we're still going to keep the if two angles part at the beginning. Let's see. So if two angles sum is 180, then they are not complementary. So again, this one's a little tricky because if you look at the first part, right now, it does not have a not, any type of negative in it, right? But the second part does. So when you go to negate it, you're taking the not out of this one, and you're putting a not in the other one. So it is possible that your statement might be made up of two separate parts, where one has a not and one doesn't have a not. And to negate it, again, you have to switch it. So the not that was there, you got to take out. The one that didn't have a not, you'd put in.
Then why is there not a knot in the thing you wrote?
So there is in this part, right? Because if two angles are complementary, that one did not have the not before, so that one needed to be negated. But then this one, their sum is not 180. That was negated by taking out the not. Okay? Yeah, again, it's just like an equation. Think of negation as being negative and positive. If you already have a negative and you do the negative of a negative, it becomes positive. All right. So that's the whole review.